11.1 Functions of time. Hit pause, make some notes. When you're ready, hit play and we'll introduce variable acceleration. So far in year 12 we've dealt with constant acceleration, and we've seen that you can express displacement and velocity as functions of time. When acceleration is variable, we can also express acceleration as a function of time, f of t. I've got a couple of examples here of acceleration as a function of time. In the first example, I've got here a couple of examples of acceleration as a function of time. First example, we've got increasing acceleration here. So it's the change in velocity, the rate of change of velocity with respect to time. And as you can see, the gradient is getting steeper. And I've got a decreasing acceleration example. Velocity, change in velocity with respect to time again. And as you can see, the gradient is decreasing with time. So hit pause, make some notes, and we'll look at an example. Okay, so this is our first example. Body moves in a straight line such that its displacement s from the point 0 at time t is given by s is equal to 2t cubed minus 3t for t greater than 0. So we've got our formula, and part A wants us to find the value of s when time is equal to 2. So if we do A over here, we've got our formula s is equal to 2t cubed minus 3t. When so let's write that down in full. When time is equal to 2, s is going to be given by 2 times 2 cubed minus 3 times 2. Okay, so we've got 2 times 8, which is 16, take away 6, so s is going to be equal to 10 meters. In part B, we're told to find the time taken for the body to return to point O. So s is equal to 2t cubed minus 3t. And we want to find the time taken for the body to return to point O. When it returns to point O, however, displacement is now 0. So that means 0 is equal to 2t cubed minus 3t. So our function is just in terms of t, so we can solve for t by factorizing the right hand side. We take t out, we're left with 2t squared minus 3. So that means that either t is equal to 0 or 2t squared minus 3 is equal to 0, which means that t squared is equal to 3 over 2, and so t is going to be equal to plus or minus the square root of 3 over 2. However, negative time is meaningless, so we're told that t is greater than 0, so that means that t is going to be equal to the square root of 3 over 2. Positive. Okay, so hit pause, make some notes. When you're ready, hit play, and we'll look at another example. Okay, so example 2. You've got a toy train traveling along a straight train track. It leaves the start of the track at time t equals 0, and then it returns back to the start of the track. The distance, s meters from the start of the track, is modeled in time by the formula s is equal to 4t squared minus t cubed, and time is restricted from 0 to 4 seconds. So our question is to explain why there's a time restriction on the model. Well, this train is leaving a point and then traveling along a straight track. So this means that s, the distance traveled, is going to be either 0 or greater than 0. So that means s is going to be greater than or equal to 0, because it starts from a point, travels, and then it returns back to that point, on a straight track. So if s is greater than or equal to 0, then our formula 4t squared minus t cubed is also greater than or equal to 0. 4t squared minus t cubed is also greater than or equal to 0. Now I can solve for t by factorizing. I've got t squared, which is common to both terms. I've got 4 minus t is now greater than or equal to 0. So this implies then that either t squared is greater than or equal to 0, or 4 minus t is greater than or equal to 0, which means that 4, it's better to do it this way around, is greater than or equal to t. So t is going to be less than 4, but t is also going to be greater than 0. Okay, because having a negative time is not going to make any sense in this instance. So that means t is greater than or equal to 0. But at the same time, t is less than or equal to 4, which is why we've got that time restriction there. So hit pause, make some notes. When you're ready, hit play, and we'll look at another example. So our third example, we've got this body moving in a straight line again, and its velocity is given by v meters per second, and we've got this formula. So in this example, we've got a body moving in a straight line, and its velocity is given by the formula v is equal to 2t squared minus 16t plus 24, and for all time greater than or equal to 0. So we've got our velocity in terms of time, got our function there in terms of time. First part of the question is to find the initial velocity. Now the initial velocity is given at a time t equals 0. So if we do a here, got v is equal to 2t squared minus 16t plus 24. Initial velocity is at t is equal to 0. So v is going to be equal to 2 times 0 squared minus 16 times 0 plus 24. So v, initial velocity v, is going to be equal to 24 meters per second. And part B then, values of t when the body is instantaneously at rest. So when it's at rest, velocity is going to be equal to 0. So our formula v is equal to 2t squared minus 16t plus 24. So when it's at rest, v is equal to 0. So v is equal to 0. So we can solve for t by setting the formula equal to 0. So we've got 2t squared minus 16t plus 24 is equal to 0. First thing I want to do is to simplify this, so I'm going to divide through by 2, leaving me with t squared minus 8t plus 12 is equal to 0. And if I factorize that, I get factors of 12, 6 and 2, so minus 6 and minus 2. So either t minus 6 is equal to 0 or t minus 2 is equal to 0, which means that t is equal to 6 or t is equal to 2 when it's instantaneously at rest. For part C, I want to find the value of t when the velocity is 64 meters per second. So let's write our formula. V is equal to 2t squared minus 16t plus 24. So when velocity is 64, that means our formula 2t squared minus 16t plus 24 is equal to 64. It's easier if we write it this way around. 2t squared minus 16t plus 24 is equal to 64. I can solve that for t. We subtract 64 from both sides. We got 2t squared minus 16t plus 24 minus 64 is equal to 0. So 2t squared minus 16t minus 40 is equal to 0. Again, to simplify, I'm going to divide through by 2. Let's put that in brackets. Do the same over here. That leaves us with t squared minus 8t minus 20 is equal to 0. I can factorize this. Minus 20, so I'm looking for 10 and 2, minus 10 plus 2. So either t is equal to 10 or t is equal to minus 2. But we're told in the question that t is greater than or equal to 0, therefore t is going to be equal to 10 in this part of the question. And finally, part D. In part D, find the greatest speed of the body in the interval 0 to 5. Now, to do this part, we can sketch the curve. I haven't got very much room, so I'm going to try my best here. We can sketch the curve in terms of v and t. And we know that initially it starts at 24. So if we say this is 24, and then it dips down to be instantaneously at rest at 2, and then at 6. So that's 6, that's 2, and that's 24. So when's the greatest speed? We can use the graph to show us the greatest gradient. We're only going up to time t equals 5, which is going to be approximately about there. So that's 5 there, 5 seconds. If we look at the graph then, the steepest part of the graph is initially. So that's our point when it's steepest. So the greatest speed is at t equals 24. Sorry, it's v equals 24 and t equals 0. V equals 24 meters per second. Okay, good. So hit pause, make some notes. Once you've done that, I've got a few questions for you, and then we move on. Okay, so here are your questions. Exercise 11A. Are there 8 questions? Yes, 8 questions. Good luck.